another. So if you look at it just on a tower basis, if you test with one tower over one technology, you're going to be colliding with a lot of other providers sharing that RF bandwidth going to that tower for one, and you're going to be, if it's a third-party tower carrier like American Tower, who may be supporting antennas for Sprint, Verizon, AT&T, you have a common pipe going downstream back to the host. So it's less concerning to test with the different carriers unless you actually have a 2G to 4G type of situation, than it is to make sure that you're testing in a representative environment, something that is sufficiently dirty for all the carriers. I like to test in what you might call the least common denominator environment. I want it resource constricted on the phone. I'll load up all sorts of apps that I know are talkative all the time, and I'll go to the dirtiest, poorest data location I can and actually test from there and see if I get a good bandwidth.
Okay. I mean, I think one of the biggest differences in the carriers is, for instance, like Verizon, you cannot do data and voice simultaneously. So when you're talking to somebody, you can't say, "Hold on a second, let me look that up on the internet and get something." Whereas on the AT&T network, you can. Have
Good
you
point on that.
have you run into those kind of instances where some applications will behave differently because of that, or is that something that we should worry about?
That's not a condition that I normally test for on the performance side. On the functional side, I can see how that would be a very distinct condition to test for. But for
Right.
performance, since most of these conversations are transport based on the performance side, it's less of an issue with collision on the functional side because they could not mutually coexist for
Right.
a particular
Right.
carrier.
Okay. Well, that's good. Thank you.
Thank you. So here we have reality. So we have 2G downgrades, we have lots of interference, we have bandwidth thieves on the device, plus you're sharing your bandwidth with the antenna, wherever that is located. And that really impacts your performance, particularly since network is really the most expensive resource that you're going to leverage. When you think of CPU, disk, memory, and network is all off device. And this all leads to a slower connection than you might expect.
So you mentioned RF interference. What kinds of RF interference should we aware of or be wary of when we're doing our testing? Or can we introduce those kinds of interference just to see how things work and in the real world?
I find motors, really dirty motors, to be the best source of interference. So if you have someone that's got a lot of generators that's around a facility that's spinning off just a lot of stuff, that's usually going to play havoc. Also, if you're in a geography which has a lot of hills and valleys and a lot of iron in the rock, that's also fantastic. So looking at the West Coast, for instance, you have all this igneous rock formation that comes from the collision of the Pacific and North American plates. There are all sorts of little pocket valleys along there. You've probably ridden your bike through there, Phil, or driven through there,
Right.
and you're looking at your phone and going, "Oh, no signal now."
Yeah, well, we certainly didn't have much signal in Yellowstone a few weeks ago. But also, I was just thinking, so you mentioned something really important. So if you're close to motors, so actually you should really be considering, and you're going to talk about this later, about the users, who the users are in the application. Like if your application is being used in a factory, you really have to be a lot more wary of the interference than if you're in an office building, I would think.
Absolutely. You want to make sure you may actually have to investigate shielding sources of RF that are being generated. You might have to investigate shielding motors, shielding any other type of radio interference that might be stealing bandwidth locally. So it is important to test in those dirty environments.
Okay.
So let's look at what this low speed problem does once we get to the server. I mentioned earlier that the network is really the most expensive resource. And as we go out and we make our connections through the tower, we have to continue to make that connection downstream to the servers that we're connecting to, either if it's a full-blown app and we're making a web services call or a socket connection, or if we're just making a request to a mobile website. These slow speed connections actually lock up resources longer on the servers than you might expect. So Phil, think about this. I've got a mobile device, I'm in a slow environment, and I make a request out for a piece of data. First thing I have to do is I have to establish a connection. That's usually an expensive proposition. I send the data over the connection, which depending upon the speed of my connection takes longer or slower amounts, or longer or shorter amounts of time. Then I wait, and then the data coming back also takes longer or shorter depending upon the speed of the connection. And then finally I disconnect. That latch time, how long I am on the server, is longer for slower speed connections. And the client-server model is built around this transient use of a resource for clients. That is, I connect, I use a resource very quickly, and I disconnect. The longer I hold onto a resource, the fewer the people other services or people I can get onto the same server, because the resource is locked. And this is precisely what happens with mobile devices. Is you have a slow speed connection, your latch time on a resource increases, and as a result, you can lock up a server with a smaller number of mobile clients than desktop clients.
Mm-hmm. So it seems to me like you would want to have very small transactions.
Well, you want to minimize your use of network to the extreme.
Mm-hmm.
And there's some things that actually work against us in this model. One, and I'll lay claim to this since I'm a former developer, developers are lazy. And if I have, say, a style sheet that covers the universe, and I can just drop it into my web page definition and move forward, I will. Until somebody tells me I need to remove everything that is not critically essential.
Okay.
And all of that usually results in larger data flows by default that need to be in place, both larger in size and larger in number.
Mm-hmm. So the goal really is when you're developing is to really just make your data transfers as small as possible, or in as little as possible.
Correct. As few and as small. Those
Yeah.
are the rules of thumb. And you'll see how our recommendations actually speak directly to that a little bit later.
Okay.
So what can we do to improve performance? Well, there are 5 main things that you can do. One is engage in performance engineering as well as performance testing. And you may have heard the term shift left, that is moving your services downstream into development. That is where performance engineering takes place. To improve predictability of what's going to happen in production, we need to improve our test network. We may need to make some operational changes in how we actually deploy to account for this longer latch time on resources. Data flow management speaks directly to the size and number of data flows. And then finally, for performance testing, know your users. Understand the split between desktop and mobile and their behaviors.
What would you, it seems like these days that, what would you say that, how is this balance shifting from desktop to mobile users? Is that for real? I mean, everybody talks about, mobile is king.
It is. These devices are on all the time. And in some cases, the applications are on all the time. Think of Facebook as an example, where it's on in the background, constantly strobing, looking for messages, getting notifications, things of that nature. So the shift is definitely there. If you know any classical website, even if it's desktop oriented, If you were to take a look at their request logs a year ago, a year before that, and today, you will see a distinct improvement in the number of mobile users versus desktop users. And today, most organizations are testing with 30% or more mobile. And this is pure mobile, not just tablet. This is pure mobile devices.
Mm-hmm. Wow.
So let's break these down and talk about performance engineering specifically. So performance engineering is that shift left you've heard about. Now, why is this important? Well, we can look at just about any study on the cost to fix a defect and where it is located in the life cycle, and we will find that the closer we can get to the origin of the project to identify and fix a defect, the cheaper it is to fix. Phil, you've probably seen defects that occur late in functional or late in performance where the cost to fix it is greater than the opportunity cost of deploying and having the issue in production.
For sure. I mean, sometimes they would just say, well, let's just do it anyway because it's too much time or too much money to fix it. I'm wondering, you know, in the second bullet point there, you say be the voice of reason for increasing the size and number of data flows. You're talking about from a testing and simulation type point of view, trying to really push the environment or push the testing. Is that what you're talking about?
I'm talking in this case of being right there at the point of design where developers are structuring the web pages and saying, well, sure, we use these 25 style sheets on the desktop site. Why can't we load them on mobile? Well, you can, but you can also put bicycle wheels on a Corvette. Some combinations don't make logical sense for the highest performance. And this is one of these areas where you can have a tremendous impact up front. So if I have, and this example actually comes from a client that I worked with about a year ago, these 25 style sheets, if I was to simply combine the 25 style sheets into one, that allows that now I have only one request I need to make instead of 25. Most web servers or HTTP architecture clients will actually have up to 6 connections that they can download information on. So that frees up 5 channels for other downloads right away.
So, I mean, yeah, it's really interesting that you mentioned that. So really a lot of the, I guess you could say, tasks or things that users are doing, when you try to just transport them from the web to the mobile environment, you have to kind of, in a way, redesign the whole task and compress it so that there's less requests.
True, and you're bringing up another issue, compression. Absolutely, that reduces the total number of bytes. And in the case of style sheets, we've all seen sites where we have large style sheets and a large number of unstyled elements present. But, you know, it's cheap, it's easy, we'll just ship everything. And in that case, there's a cost associated with it. Because not only do you have to ship that to the client, but then on the CPU, on the client side, the CPU has to go and parse through all of these unused, unstyled items. You have to manage it in RAM. So there are other costs, but the cost locally is not as expensive as bringing it across the network. Going along with this, it's real simple to begin collecting timing information from development and functional test. If we just find out when the test starts, when the test ends, or for a timing record, how long a page takes to load, we can, in fact, begin looking at changes over builds. It takes unit test 32, 180 milliseconds to run normally. If all of a sudden it goes to 720 milliseconds, it may pass, but do we really want it to move forward in the build until we understand why?
Now, are there any types of typical tools that people use for this, or is this something that is at the developer level where they have to actually insert these into their code in order for testing to happen?
It's very common these days to use tools like JUnit or some of the unit test tools that are built into Visual Studio. So developers are already using these tools, and very often it is the case of simply asking them to collect an additional data point, or to take the test information that comes off of it and pull the metadata for when the test started and when the test ended, so then you can look at the delta for how long something takes. Now, on the functional test side, it's a little bit different. For whatever reason, in functional tests, questions related to performance are not often asked. We're very good at asking the question of, does it work for one? We have a set of requirements, we go through it, but are we asking the question in functional, is the page fast enough? Is the request performant for one user? And if not, it's a missed opportunity, because what will happen is it will pass through the functional gate, it will get to performance testing, and performance testing will fail it. It's more expensive because it's a little bit later in the product life cycle. If we can fail it earlier as a functional defect, it doesn't work for one user, we can actually save costs in this case.
So I guess in a way you're saying that rather than go out to production and do load testing, in other words, you have to kind of backtrack and say, well, if we can accept a certain level of performance with 500 users doing certain things, then what does that translate into one step before that with one user?
Exactly.
Yeah.
And if you're running a single user and you find that just logging in takes 30 seconds.
Well, I mean, you you could say if logging in with one user in my laboratory takes 30 milliseconds, whereas it used to take 5 milliseconds, then 30 milliseconds is even too much, right?
That's true. If you have a dramatic change from one build to the next, you at least need to understand why.
Right.
And it could be related to an environment change, a data change, or a code change. Your code has gotten more sophisticated. But if you can't explain it, that there's a lot of danger there. And clearly when you have SLAs in effect, such as if you're checking out through a shopping cart, and if we go from 5 seconds to 10 seconds, we have a 50% drop in conversion, as an example, then you want to make sure that even as a single user, you're at that 5-second level or better for all of your tests, or it goes back to the drawing board.
Right. So, what kinds of, maybe that's, I guess we're probably going to cover this later. I just wonder what kind, if you do wait until the last minute, what kind of tools do you use to do those kind of load testing to simulate mobile transactions?
And in the last stage, if you're waiting for performance testing, then you're looking at the classical performance testing tools. You're looking at LoadRunner, JMeter, SOSTA, Silk Performer, anything that can generate load in that sense.
Yeah, that's kind of like too late though, actually, huh?
It gets expensive to fix at that late scale, and these architectural changes of combining style sheets, of trimming them down, things of that nature. If you start making these wholesale architectural changes to the pages at the last gate before deployment, think of all the costs that entails. You now have to go all the way back to design. You have to go all the way through a whole bunch of functional test stages to get back to performance before you can go through the release gate again.
Right.
So it's very expensive. So if you're going to sell this to your organization, it's find it early, fix it early, avoid the cost of fixing it later downstream.
So, in your experience, James, I know you do a lot of consulting with developers and things like that. Is this typically an issue that they wait to the last minute, or where do you think that they could get the most bang for the buck and the easiest thing for developers to do to move up to, or move to the left, so to speak?
Well, as the industry is experiencing a large shift towards continuous integration, development, tests, and deployment. Agile or DevOps. It's under a couple of different banners. But the model that all of them seem to be employing is this co-location of testers with developers. So as developers write code, testers have input to that and writing the test cases and things of that nature. So if the two groups are working together, collecting that additional piece of metadata for how long something takes, and then tracking it from one test to the next or one build to the next or day to the next becomes very easy. Most developers just don't know to track that. It's like, okay, test runs, it works. It's the classical, it compiles, it ships in that case. And if they know to track it and they understand the value of tracking it, even better. And having that close work proximity certainly helps. The classical model, which is still employed for a lot of businesses answering business questions and performance, is often too late to affect these major changes which have the most benefit. Ideally, when you get to a traditional performance testing stage, you should be looking at environment configuration changes. If you're looking at code changes at that point, there's some process things that need to change.
Right. James, there's a question coming from the audience. They're asking about the Marvin Veracode test framework. Do you know anything about that?
I cannot speak to that.
Okay.
But I'll make a note to go and take a look at it.
Yeah. Go ahead. Sorry for the interruption.
That's okay. Next up on test network improvements. You're going to like this one a lot. Get dirty. We live in a very sanitized network test environment typically. I know corporate environments, people say, hey, the network is dirty. We have all this extra traffic running. But compared with what's going on out in the wild, a corporate test network is fairly controlled for RF, for resource thieves that are ongoing, things of that nature. So I like to get out and drive around. I've seen some organizations that have vans outfitted. You just go out, drive around town, testing on a functional basis just to make sure things are working. The van can be a good option, particularly if you have a pre-release piece of software and you don't want the public to see it accidentally, which can happen if Phil or I were to just take a phone and go out and have dinner and work the app for a little bit. So keep that in mind. This becomes a little bit more difficult when you're looking at performance testing, however. There are ways that you can add more realistic impairment to your network environment. Now, Phil, are you familiar with speedtest.net?
Yes, I am.
Yeah, I think everybody has seen this at one time or another. You call your cable company, you call your DSL provider, and they say, well, you think you're having a bandwidth problem, let's go to speedtest.net, run a test. The back end of that is from a company called Ookla, and they collect data from all around the world. So I can go into the Ookla database and I can pick a set of data from Zambia at rush hour just before a holiday and understand what that mobile or physical network looks like so I can model that in my test. That has a lot of power, an incredible amount of power. But some tools are better integrated with this data than others. You can look at an open source tool like WAN-M, which is not very well integrated with this data set. Essentially, you're going to have to plug it in by hand. It doesn't cover the richness of the data as bandwidth goes up and down, as error rates go up and down as a part of the Ookla data. when you look at tools from companies like HP for their Shunra integration, Ixia and Spirent, Ixia and Spirent being more network-centric as test tool providers, they're more fully integrated with this Ookla data set. But what this does is it brings the benefits of going into the wild into your environment. And this can be leveraged for functional testing. It can be leveraged for performance testing. It could be leveraged for what-if testing. What if we expand to Indonesia? And now, so we have people from that location in the world coming back to California where our data center is located. What is their experience going to look like if we change the network?
You mentioned adding impairment. Is there ways to do that in a controlled environment to kind of see what the threshold is for certain levels of speeds or errors?
Certainly you can do that. Think of Shunra
Yeah.
as a network appliance or software solution. There's WAN-M as another example. So you definitely have the capability of adding this in a controlled environment and getting the benefits of the in the wild situation.
Right.
And you can tune it down to such a low degree. That is, you could, for instance, if you were testing failover testing on your network, you could make one network link could go to 100% error. So it looked like there was a line cut. This didn't happen. So you could get bandwidth low enough to understand where your application simply will not function any longer, which is great from a functional perspective.
Yeah, I guess the key thing really is to see how your application responds and recovers from those kinds of situations. And I guess to do that, you'd have to have a lot of extra code in there to respond to those things.
True. If you have a mobile application, it's a lot easier to control that code than if you have a mobile website. For mobile websites, it really comes down to the page architecture. How many and size of data flows. For a mobile app, you can take advantage of algorithms to back off and retry. You can supply rich messages to the user interface saying, hey, we're in a low network situation. We'll retry at some future time.
Right.
So, but for mobile websites, it's all about design in that case.
Right. Yeah, I just hate it when Siri says to me, sorry, I cannot take your request right now. There's a problem.
And you're right there in the valley near Apple.
So that's actually, it's interesting. That's kind of a hybrid because that resides locally, but it's also interacting with the server, and so I guess locally it senses that the network is not up to par, and it just says tries to come up with some excuse, right?
That's a great example. That is a great example.
Yeah. Okay. Great.
This one is a little unconventional. Because you have the longer latch time from resources, you may want to consider installing a different infrastructure for your mobile users. I mentioned earlier that mobile users can latch onto a resource and hold on to it for a longer period of time. And if you have both your desktop and your mobile users going to the same servers, you can exhaust the network infrastructure pieces with your mobile clients and actually freeze out your desktop clients. Effectively, your server's down for a period of time. Now, if you were to handle that by redirecting your mobile clients to a different infrastructure from your desktop, you can buy insurance in that case. Instead of impacting all users, if the mobile users get locked up, you're only handling a portion of your user population that you're inconveniencing. And if it's an app, like you said, for Siri, you can say, hey, we'll try again later, that type of item. Not to be left out in this is the tablet community. The user agent of a browser typically identifies whether a client type is mobile or not, except in the case of a tablet. Tablets don't identify as mobile browsers. So in most cases, they will go to the desktop portion of your website. Different GeoIP providers have the ability to tell you what type of network a connection is coming in from an IP address perspective. It's a very easy check to simply say, if mobile is part of the user agent string, go to my m.dot site. But if you have a tablet coming in, something that identifies as iPad or Android, but doesn't have a mobile keyword in it, you'll likely want to perform an additional check on that client at the top of your web page or your introductory page to the site to see if that client is coming across a cellular type of network. And if so, send them off to your m.dot site for that experience. And the reason being, once again, is because they have that longer latch time on resources. And if you were to send them to your desktop site, which arguably should be just as efficient as your mobile site if you want to have the best performance, it can lock up resources there and impact your desktop population. So this is a little bit of operations and a little bit of development. That is checking the web page when it comes in. Is it mobile? Yes, go to the mobile site. Is it tablet and on a cellular carrier? Then go to the mobile site as well. Any questions, Phil?
Yeah, I was just wondering, how that ties in with a lot of these responsive design tools. With a lot of these responsive websites and responsive web apps, it seems to me like the m.dot is going to go away. What do you think about that?
Well, Phil, I notice, I think that you're using WordPress on some of your sites.
Right.
And on WordPress, depending upon the template you have, there's a different experience for mobile than there is for the desktop, kind of an optimized experience. I'm not sure for these rapid application development models that is perfectly optimal for large loads of users.
Yeah.
I think it works well for smaller populations of users where the site is not active all the time and under stress. If you get to a large commercial website, if you get to a site such as Facebook, if you were to go to, say, Motorola today to look at their Moto 360 watch, which I don't recommend because they're kind of crushed right now with that announcement, you'll see that they have an optimized site, and it's not just you going to XBOSoft and getting a mobile experience.
Yeah, yeah. Of course, it's a lot more complicated and different than if it's a real application versus just information that you're accessing on the site.
Yes, yes. And like you, our organization, we use Drupal that also has some similar mobile capabilities. But if we were going to do a full-blown live app, I think we'd go for a separate virtual machine with a separate infrastructure just to manage it.
Right. Okay.
So
the GeoIP, how does that work?
So GeoIP, every single IP address is pinned to a location on the internet, which is a location in the world. And different blocks of IP addresses are owned by different providers. So Verizon may own a block, IBM owns a block, Microsoft owns a block. So these source providers for GeoIP data exist out on the internet where I can query by IP address and get all sorts of metadata coming back about the provider. It can tell me the country that the IP address is sourced from. It can tell me the network provider. It may provide who is information in the case of a corporate environment such as IBM or XBOSoft or NewCOE. It can also provide network type such as cable, fiber, Ethernet, cellular, dial-up. And in cases where you have a very slow network speed, performing the extra check on IP address for the type of connection can ensure that you're sending your client to the best performing environment for that client type. So I'm an Android tablet, but I'm connected over what appears to be Ethernet, which would likely be a Wi-Fi connection in somebody's house. Absolutely, send them to the desktop site.
Right.
Now I've left the house and I have a cellular connection inside my iPad, and I'm connecting across the cellular carrier. I would, since that's a much slower speed connection, arguably I want to send them to the MDOT site if I have an option.
Well, that's going to require a lot of coding and thinking up front about the different types of devices and so forth and networks out there.
Fortunately, they fall into a couple of pretty clear categories. The mobile devices always identify as mobile. Phones do, and the user agent string connecting in. For the items which are not identifying as mobile, they really fall into a couple of different categories for tablet providers. There's either Android or there's Apple. So you've got anything that identifies as an iPad, one extra check, or anything that identifies as Android but doesn't have mobile in the user agent string, then there's one additional check.
Okay.
So it's a pretty clean design in that case.
Right. Well, we better get going here. I'm asking too many questions. We're going to run out of time, James. Sorry about that.
Okay. On the data flow management side, a lot of this is a repeat of what we've covered earlier in the broadcast. Go for the minimal number of data flows, the minimal size on the data flows. In addition to that, we want to make sure that you're appropriately managing cache. A good example is font files. For whatever reason, people forget to manage their font resources effectively. These things should be cacheable for years on the client. If you have return clients, don't force them to constantly re-request font files. And finally, watch the 404s. With highly styled websites today, very often we don't see the missing resource. If there's a missing JPEG, it's hidden from us on the web page. But it still occurs. We still have a resource request and we still have a miss. That's a very expensive request for a lot of reasons. One, if you're managing a lot of your content in a content delivery network such as Akamai, that request has to be tunneled all the way back to your origin website. And then it requires 2 disk writes, one for the request and one for the error. So you've now created a connection from a mobile device all the way back to the origin servers instead of handling it as close as you can to the client on the edge in the CDN network. And because those are often ignored, they can represent a significant load on origin web servers. For one of our customers, this represented over 25% of all the requests on their website, 404s.
Wow.
And developers, it's like, oh, we don't want to fix them. We don't have time to fix them. I usually go in and I stub them out with a single pixel alpha channel file or a single byte JavaScript or a single byte HTML, whatever the missing file type is. I make it as small as possible and as invisible as possible, and then it gets picked up by the CDN, and then all of a sudden those requests disappear. Arguably, these should be caught in the functional test stage. Just because it's not visible, always look at the developer tools and make sure that you don't have missing resources that you shouldn't cite as a defect. For external references, pick up a copy of Steve Souter's High Performance Websites. A lot of the concepts that we're covering here related to network as an expensive resource are covered by Steve as a part of his documentation for building high-performance websites. These apply equally to desktop as well as mobile, but especially for mobile because of the expensive nature of the network connection and pulling data back across. Also, as a tester, all of your developers are going to be familiar with Steve Souter's work. So if you have to show up in a meeting and someone says, well, why should we do this? Take Steve's book, put it on the table and say, oh, because Steve said so. instant credibility.
Well, how about if we just say if James said so?
Well, you know, all the developers don't know me, and I don't have a book that has my name on it that's in their bookshelf
Okay.
yet. You know, maybe I should work on that. But just about everyone will have something from Steve. High-performance websites, more high-performance websites, or higher-performance websites. They're very popular books. They're very well written, and the concepts in there are very good. So if you're going to cite a resource that they know and love and trust in that sense. And then finally, knowing your community. This is critical, especially if you're performance testing. You need to know how many users of each type are connecting in. How many are mobile, how many are tablet, how many are desktop, and how they are connecting. Go to your logs. This is your authoritative reference source. Look at each IP address. Look at the user agent string for it. Find out how many users are coming into your site on an hourly basis, monthly basis. Find your high volume hours during the year. And model the changes from month to month. You're likely going to see that your mobile population is growing. And you need to project out what that's going to look like 12 to 18 months. You may not have an opportunity to test this application in full before it goes to production again. You may be getting patch releases. A project manager may decide, oh, the risk is low, we're not going to performance test. Project out 12 to 18 months and test for that that maximum out of tolerance condition at that point for both numbers of users as you're growing as well as the types of users. And yes, find a way to get network impairment involved. Even if you have to rent a device for a short period of time, get that network impairment because you want that longer latch time on the mobile resources so you can see what happens to your user community under load.
You mentioned something that was kind of a issue for a lot of our clients. You said renting a device. So, you know, this just kind of an aside, using real devices versus simulated devices and so forth. What's your 30-second answer on that in terms of what you would recommend?
Well, in terms of devices in this context, I'm looking specifically at network impairment devices.
Okay.
So if you need network impairment, if you don't have a solution in-house, find a solution to rent it for your testing period. Or go to a test lab that already has it in it. A lot of test labs, such as the test labs from Microsoft, Oracle, well, Sun when it was a part of Oracle, IBM, they all have network impairment solutions in place.
Right.
And if you're taking advantage of their hardware and you have access to their test lab, leverage it. It can often be cheaper to go to the test lab than it is to rent the device directly from the manufacturer.
Yeah. Okay. I don't think we have any more questions from the audience, James.
Well, I've covered all of my points, Phil. What about you? Do you have any more questions just coming from your background, what you've seen, and mobile challenges that your clients have faced?
Well, you know, you mentioned your last slide is about the community, and I think that's probably one of the most important things is to look at the users and what they're doing. We mentioned earlier about you know, motors impacting the performance, and so you really have to think about where your users are using your application, and all that has to do with context, right? And context is really getting to be a big word these days in terms of the data that's collected based on your context, and that's going to continue to fill the pipe and put pressure on performance of the software that's processing that data on the client, in this case a mobile, as well as on the server side. So the problems are not going to get smaller, they're going to get bigger as more and more data representing the context of the user keeps getting transmitted to the servers. It's just really an exciting time, I think.
Absolutely. And one thing that is a trend that is very much impacting mobile environments are these always-on applications. I'm of mixed feelings about them. On the one hand, this push notification type solution where, hey, you have a message from somebody, this event has occurred, I need to take action. It does improve efficiency on occasion. It makes it a little bit more difficult to disconnect if you want to have a day off, but it does improve efficiency. On the other hand, it places a tremendous stress on your application infrastructure, including your network, for all these push notifications. And that can cause your infrastructure to have to be upgraded at a faster cycle than you're used to, because you have this constant noise from applications that is growing in your network.
But users are starting to expect that as part of every application.
They are, and that's why I said I'm of mixed feelings on it. I can see the benefits of this type of always-on push notification. The drawbacks being the infrastructure cost. If we were to look at some of our other colleagues, they might say, hey, have you ever wondered why your phone is always hot? Because you're running an app that is constantly using the GPS chip.
Right.
And you're running out of battery all the time as a result, too. So there's a trade-off there from a performance perspective.
Okay. Okay, well, I think that's all I've got, James. Thank you for being our guest today on the webinar. I think it's been a great learning experience, learning from you and some of the issues that we've got in doing performance testing for mobile.
Phil, thank you for the opportunity to speak to your community of users, or your community of customers as well. And if there are any additional questions that I can address for your community, please take advantage of the contact information that you see on your screen. And Phil will get that information to me, and we'll get it back out to the community.
Yeah, we're going to be, we've got webinars coming up towards the end of the month, and we're going to be posting the questions, the question and answer dialogue that we've had on our blog. So anybody who wants to get in there and see the questions and answers, or actually even ask more questions, feel free to do that. We've also got a lot of white papers, some of which are related to mobile performance, so you might want to go and download some of those. And thanks everyone for attending.
Have a great weekend, everybody.
Okay. Thanks, James.